Okay, today let's talk about Atcoder beginner contest 374 problem E. First part is a description. The manufacturing of a certain product require n processor named 1, 2, 3 till n. For every process, there are two types of machine, Si and Ti, available that can produce this kind of process. For each kind of machine, for S, it can process AI products, actually AI processors per day per unit, and cost PI per day per unit. For machine T, is the same situation. Machine T can process BI processor per day per unit and cost QI per unit. You are given a totally budget X budget. What you need to do, actually, there is another definition. The production capacity of the whole product is the maximum capacity of all processor. What you need to do is make a great strategy that make the return the maximum production capacity of the whole product. That equal the minimum I equal 1 n all processor. That means the production capacity of this product is the minimum processor production capacity among all processors. This is the you can buy any number for each machine, S or T. Maybe 0 is also acceptable. It depends on you. This is the description part of this problem. Next part, let's talk about solution. This is a funny problem, at least for me. Actually, a very direct solution to solve this problem is use binary search. More specifically, for every answer you can check a capacity. You can check capacity is available. If it is available, you can increase this value and check the larger part. If it is not available, you should switch to the left. That maybe that means the smaller part of the whole interval. So the more important about this problem is how to define the check function. Actually, you can more specifically you can check the given capacity from processor 1, 2, 3 until n. If all processor is available for this capacity, it is available in the it is available finally. If any of the processor is not capacity for this, it cannot be available. Actually, what we need to do is for every processor, you are given an capacity, and for each processor, you should we can compute the minimum budget we need, or money we need. We can calculate this for every process. M2, M3, Mn. We can sum this money and get total money. We can check if it is larger than given budget. If it is larger than budget, so it is not available. If it less or equal the budget, it is acceptable. This is the define of the check function. So we change this problem to more small question: how to get for each process, how to get the minimum money. For each processor, we are given capacity. How to get the minimum money? More specifically, we are given these values as below. A, P. That means we are given two kind of machine information, S and T. For S, it can produce A processor and cost P. For T, it can produce B and the cost is Q. What we need capacity is we made it C. So how to buy a certain number machine S and machine T to produce the capacity C? That means, for example, we need buy machine S and Y machine T. That means we need guarantee Sx plus Y multiply B is larger or equal capacity C, and make the P X plus Q Y minimum. Make this value minimum. So it's very hard. Okay, let's talk about the limitation about this problem. A or B are between 0 and 100, but B or Q 1. Okay, this is what we will know. Actually, for machine S or machine T, there always will be a better machine because we can calculate the ROI. That means return over investment. That means A product A dev by P, B dev by Q. If the left value is larger than right, we should use left as much as you can. In contrast, if A, P, B, Q, so we should use the right as much as you can because it can produce more product, more processor based on the same budget, based on the same using the same money. This is the key part of this problem. But in some specific situation, we need buy another. For example, let's take the first situation as the example. We can buy the machine S. That means use the AP. We can buy machine S as much as I can, but maybe if we don't buy any machine T, it costs too much. That means we don't need produce that much machine. For example, let's take the example. Let's take some example. If the A is 6 and P is 3, the B is 1, Q is 1. So, and the capacity 0, 3, 1, 1. Let's make the capacity what we need equal 7. If we use situation 1, if we buy machine S as much as I can in order to produce 7 per day, we need buy 2 S, 2 machine S. That means we need cost $6. For if we just buy 1 S, that means we cost and 1 T. That only cost 7. This cost 2. That means cost 2, 4, 6 plus 3. We only need 4. That means 3 plus 1. So maybe we don't need. We cannot buy all S and buy nothing about T in some specific situation, but we still should put one of S and T. Actually, this situation is S. We should buy S at the majority of this situation. This depends on the ROI of which machine is better. After we buy enough S, what is the number of T that we should buy? How to depends on how to calculate the number of T we should buy. This is a hard problem. So actually I didn't make this sort by myself. So I watch other people's solution and find out the correct solution. That means for B, what we need, the most possible value that we will buy is 8. Why that? Actually, we can make this situation. Okay, if we buy B, we buy the number. If the number of B we should buy is larger than 8, that means we buy Y is larger than 8. So we can make Y plus 8Z. This is another constant value. So the B, the code for the B, the production of a machine T is B plus 8 plus Z. The cost of T, that means Q plus 8 multiply plus Z. It equal AB plus B Z and AQ multiply Q multiply. This is not the best situation, because if we produce this production capacity by machine T, we can produce this by machine S, because S have better ROI. We only need to buy, if we produce this kind of capacity, the number of machine S we need by is A plus B D A that equal B plus A B D. And we can produce this kind of production by A. This is very easy. Maybe we can make the Z is 0. If we made the 0, so we can buy B, but the number of machine S we should buy is B. We can produce this kind of capacity. That means if we buy more machine T, we can do it. We can produce that through machine S. That will be the better solution. So the conclusion of this part is there is a limitation of we should buy the node-based machine. The limitation for machine T, the limitation we should buy is A. For the limitation of machine T, limitation is A. For the limitation of machine S, the limitation is B. So we don't need buy so much that. Yes, that means we can loop or situation that is possible for the best situation, because the A and B is very small, that the largest number limitation of them is 100. So this is the solution part. For the third part, let's talk about complexity. First is time complexity. For the time complexity, first we need a binary search that will cost log of 100. Maybe that should be 10 millions, log 10 millions, because the limitation of the answer is the limitation is 1 billion. So the time complexity for binary research is log 1 billion multiply. Second thing, we need to process we should to check every process, because if you want to produce a whole product, you need to produce every processor. That means we multiply n. For every processor, the time complexity should be the maximum. That means we can try every situation for the number of not best machine, and make the least capacity to another machine. So the number of situation we need to loop is 100. So this is the time complexity of this problem. Okay, let's talk about space complexity. For space, we don't need extra space complexity. So actually, it's only we don't need extra complexity. So the complexity will be as same as input. It will be n plus 4 equal O. Okay, this is all about this problem. It's very funny. It costs half day of mine. Okay, hope you enjoy.